Hello everyone, welcome to today's session on physics by Stutors for class 11th. So before going to the video, subscribe our channel if you haven't done that yet. Also enable the bell icon to get daily notifications. So this video is actually meant for the beginners of class 11th and also those science students who haven't chosen mathematics. Okay, so we are just learning some basics of calculus which will help you to learn the physics subject. Calculus is a branch of mathematics which mainly deals with the study of change in value of a function as the points in domain changes. So there are two branches for calculus, differential calculus and integral calculus. So differential calculus actually gives a measure of how a function changes its value as the input changes. For example, if we have a function f of x is equal to x square. So differential calculus actually studies how f of x changes when the value of x changes. So we know that when x is equal to 1, f of x is 1, x is equal to 2, f of x is 4. So it changes in a particular manner, right? So differential calculus actually helps us to study how this function keeps changing as a variable is changed. So this practically we use it mainly for defining the tangent lines to the graphs of function and for calculating the slope. So here we have a straight line graph, right? And let's try to find out the slope of this graph. Yes, quite simple, right? Yes, we can choose 2 points. Here we can choose 2 points and yes, we can draw a triangle, it's supposed to be straight, and we can find the tan theta, right? It's quite simple. Tan theta we can find by finding if this is x1 comma this point is x1 comma y1 and this point is x2 comma y2, then we know that the slope tan theta is y2 minus y1 by x2 minus x1. Okay, so whichever 2 points you take, you know that the slope is always same, right? Because the theta is quite the same, so the slope remains the same. Okay, so far so good. Okay, but here we have a curved graph, it's not a straight line. So how do you think we can find the slope of this graph? For example, let's take a point here and try to draw the tangent. It's not exact, but yeah, we are drawing a tangent and we find the theta, and we can find the slope at this point. But at this point, the slope is entirely different, because we can see if we are drawing a straight line, the theta would be different, right? So we can't find the slope of this graph as simple as how we found the slope in a straight line. We will need some method because the theta at every point keeps changing. Okay, so in the animation we have seen how the slope of how the tangent of the graph keeps changing at different points, right? So let's take 2 points. Yes, let's take 2 points, one here and one over there, and we have drawn 2 tangents, right? Yes, we can see that the theta is totally different. So that's why we need some method to determine the tangent of this graph. So what we do is very simple. We are taking 2 points and we are like how we tried to find the slope in the case of the straight line. Similarly, we are going to find the slope of this graph too. Yes, we took 2 points and we are drawing a triangle, but here we have a problem. Yes, this is a curve. Yeah, we are considering this thing. So this is a curve. That's not a straight line. Right? What can we do to make this curve a straight line like this? What we should do is we should bring both these points, this and this point, closer. Like let's take the animation. So in the animation we saw that how the curved line becomes a straight line as the 2 points come closer. So what did we actually do? We had 2 points and we brought them closer. So we know that the slope or tan theta is delta y by delta x. So what we did was we limited this delta x to 0. Yes, we made this delta x to 0 and we found delta y by delta x. That's what we are doing. See, if we can see we have a small triangle here, right? Yes, and that the hypotenuse is a straight line now, unlike the previous case. So now we can find the slope at this point. The limit of the ratio delta y by delta x as delta x approaches 0 is called the derivative of y with respect to x and is written as dy by dx. Is that okay? So this dy by dx is what we called as the derivative, and yeah, we got that by limiting the delta x to 0. So it's quite similar, we need not complicate it. In the previous case we had actually had the function y equal to x square, right? So we are just checking how this y is changing with respect to x. So we limited the x and we are checking how the y keeps changing. So that's dy by dx. So in this whole differentiation process, we are taking different functions like y equal to x square here. Yes. So why are we learning calculus here? In a physics course, why are we learning calculus? So we have so many applications in physics, and you will come to know that many of the derivations and many of the ideas are actually explained using the tool calculus. So physicists use calculus as their main tool in order to explain different phenomena. Okay. So in terms of derivatives, instantaneous velocity and acceleration as are defined as, okay. Now here we know that velocity is change in its displacement with respect to time, right? So imagine a body is moving at equal distance at equal amount of time. So when t is equal to 1, h is also 1. When t is equal to 2, h is also 2. So we can write as h is equal to t, right? That's our function here. So like how we had y equal to x square there. In this case, our function is x is equal to t. So we need to find how x changes with respect to t. So imagine that if that's not a straight line graph, if x, the distance covered is not same with with equal intervals of time, so then we won't get a straight line, we will have a curve. So how to find the slope? Slope is velocity in the case of displacement versus time graph. You have studied that in class 9th, right? So if we have x versus t, and if we have something, a graph like this, and we need to find the slope. So we, as we did earlier, we will find delta x by delta t, and which we know that won't be exact. So we limit the delta t to 0. Yes, we limit delta t to 0, and that's how we get dx by dt, and that's the instantaneous velocity. Instantaneous velocity because at that instant of time, we find the velocity. And similarly, acceleration, if we draw the same graph with plotting velocity versus time, we will get the value acceleration. So you have seen here d square x by dt square. It's very simple. It's just you know that v is dx by dt, right? Yes. You know that v is dx by dt. Now we have seen acceleration as d square x by dt square. Don't get complicated. It's actually the second derivative. So you know that v is dx by dt. So what we are doing is we are just now differentiating this v. So we will have dv by dt. But we know that v is equal to dx by dt. So it's like d by dt of dx by dt. And we will have d square x by dt square. This this is actually same as this. I hope it's clear. Algebra of derivative of functions. So in order to deal with differentiation, we have some golden rules which will help you to find the derivatives of different functions. Okay, so imagine you have a sum of two functions, like a polynomial like this. If you have x square plus x, and you have to find the derivative of this. So consider this as two different functions, f of x plus g of x. So how can you find the derivative of this function? Yes, the derivative of this function is actually, yes, so the derivative of sum of two functions is actually the sum of the individual derivative of the functions. So if we have f of x plus g of x, it's actually d by dx of f of x plus d by dx of g of x. Very simple, right? And similar is the case for difference. When you have x square minus x, first find the derivative of, and if you want to find the derivative of this function, first find the derivative of this and separately find the derivative of this, and you can subtract it. That's what this says. When we have a sum and difference of functions, how to find the differentiation we have already learned. So imagine now you have a product of two functions. How will you do the differentiation? So here you have to be a little bit careful. It's not direct, and this is very important. This is really important. So what you have to do is, you have two functions here, right? So first you have to you can name it as first function and second function. So first you have to write the first function as it is, and you have to find the derivative of second function. Then you have to write second function and find the derivative of first function, and you have to add these both. Then you will get the derivative of this product. So here actually if you're new to this, this g dash of x just mean that dg by dx. Okay, don't get worried. G dash, f dash, all of them just means derivative. Okay, so let's think of an analogy to understand it quite better. Imagine this is some kind of operation, I mean the medical term operation, and some guy is having two kinds of disease. Okay, so one is something related to the legs, something, and the other disease is something related to the head. Okay, head. So when you have two diseases, you won't treat them together, do we? No, we don't. So what will we do? We won't touch the leg disease first. We will just operate the head disease, and after completing that, we won't test the head disease. we will then operate the leg disease. Okay, so we are actually yeah, this is a simple way by which you can remember this, because this is a little bit confusing rule, but this is very important. uh, so it's better if you understand this in some of this way. Now we have a quotient rule. So we looked how the product rule works. So we have a quotient rule. So quotient rule is applicable only if the denominator function is non-zero. You know that if the denominator function is zero, it becomes infinity, and yes, we can't find the derivative. Okay, so for that, first you have to write the denominator function as it is, and then yeah, and then you have to find the derivative of the numerator function. So first you are finding you are starting with the numerator. Okay, you're finding the derivative of the numerator function and multiplying with it with the denominator, and you are subtracting. This you have to be very careful. Most students make mistakes here. So you are actually subtracting, whereas in the case of product rule you are adding. Here you are subtracting, and yes, and you are writing the next term is first you are writing the numerator and you are finding the derivative of the denominator, and you are dividing it by the denominator square. So this can be a bit confusing, but once you learn it properly, then it will be quite simple. So I would recommend you to be thorough with all of this now itself, because anyway you will have to learn this in mathematics in class 11th as well as 12th, and however long you are learning physics and maths, you will have differentiation and integration with you. So these are very basic things you need to know. Okay, now yes, now let's move on to some derivative of polynomials and trigonometric functions. Don't get worried, okay? These are very basic, basic results which you have to learn, or by heart, whatever you call it. You will actually learn the derivation, how it comes in your math chapter, but you will have to wait till then. Your maths teacher will be teaching that. So here we are just learning the results so that it will be easy for you to derive certain mathematical explanations for certain phenomenon. So that's why we are learning it right now. Okay, so we have if the function is a constant, then the change uh, in the function will be equal to 0. It's actually understandable. Okay, if the function is constant, it will be a straight line. The if imagine our graph is y equal to 1, so it's a constant, this is a constant, right? So the graph will be this. So we see that there is no change in the y, only x changes, y remains same. So that's why since there is no change and the slope is 0, we have this d by dx of the function is 0. And if now if the function is the function has a constant in front of the variable, so here we have ax, here x is the variable and a is the constant, so you can actually take a out. Yes, you can actually take a out and find d by dx of x. Yes, that's also shown here. Okay, so if you're having a constant, if the function is a product of a constant and a variable, separate out the constant, because you know that constant doesn't change, right? So we are taking it out and we just find the derivative of the variable. Okay, so now we have a very important result. This, it's finding the derivative of polynomials. This you have to by heart. Yes, if for example, if the term is x square, For example, if the function is f of x equal to x square, and if you want to find d by dx or f dash of x, then you have the formula nx power n minus 1. Here n is 2, so 2x power 2 minus 1, that is 2x. Yes, it's that easy. So that's how you find for any polynomial like x square, x cube, x per n, until any polynomial you can find in this way, and this is quite important for you. Now we have the derivative of some trigonometric functions. It's better if you can by heart at least these two at this stage, and also the rest of the trigonometric functions. Anyway, you will have to learn it by the end of class 11th. So I would recommend you to make a chart of all these derivatives of all these functions and have it near your study table now itself, so that by the half of this year you will be seeing it every day and you will become thorough with it. Okay, so now let's look on to some practical applications of this differentiation. So one of them is maxima and minima. So let's take a practical example. So imagine you are throwing a ball up into the air and you are plotting its distance versus time graph. So it will go up and it will have a point, it will come down, at which it will come down, because the ball goes up and comes down, right? Okay, so if you check this graph, you know that at some point the distance was maximum. So practically we know that when we throw a ball from the ground, the distance is maximum when it reaches the topmost point, right? So after reaching the topmost point, it actually comes back. It doesn't go up, it doesn't shoot up, it just comes back. So there is a point of time when the velocity is actually zero, when the body is actually not moving. I mean, you can't say that, but the velocity is zero. That's why it comes down, right? The acceleration due to gravity, it pulls back the ball. You might have learned it in class 9th. Okay, so here we know that at this point, yes, this is the maximum point. At this point, the slope is actually zero, right? So we know that at the maximum point the slope is zero. So we know how to find the slope. That's dx and dx by dt. And we also know that at the maximum point this dx by dt is zero. Yes, that's it. So that's how we find the maxima or minima. Okay, there is another possibility, it can be maximum or minimum, because imagine we have this graph going like this. In that case, you know that the slope at this point is also zero, right? The slope of that point is also zero because the tangent is at both places is horizontal. Yes, when you equate the first derivative to 0, you will get some value for your x. You will get some x is equal to maybe c. So what to do is you find the second derivative. And substitute the value of c. You are actually finding the second derivative and you are substituting the value of c. So you will have if the value you get, if it's negative then it's maxima, if it's positive then it's minima. Just opposite kind of things. If it's negative, let's make a note of it. If it's negative, it's maxima, and if it's positive, it's minima. Yeah, that's it. Okay, so now let's try to do a problem. We have a function minus x cube plus 2x square. So f of x is equal to minus h cube plus 2h square. So we need to find the point at which this function has a maximum value and a minimum value. So we know what are the steps. First we need to find the first derivative of this function. So we need to differentiate. So d by dx of f of x is given by, we know that it's, first we'll write the minus, then it's of the form h power n. So we'll write 3h square nx power n minus 1 plus there's a constant 2 and h square, again n power n minus 1. So it will be 2 into 2x. So that's minus 3h square plus 4x. So we know that at the maximum and minimum point, this first derivative is equal to 0. Yes, the slope will be 0. So we need to find the values for x at which this condition can be applied. So, yes, for finding that, we are just rearranging. So now we know that either x is equal to 0 or this bracket should be equal to 0. I mean the content inside the bracket should be equal to 0. So either x is equal to 0 or x is equal to 4 by 3, right? Am I right? Yeah, x is equal to 4 by 3. So we have 2 points. Now we need to know which is the maximum point, which is the minimum point. So for that we need to find the second derivative. Okay, so before that, let's try to plot this graph, the graph of this function. So the graph of the function will look almost like this. Okay, so the points which we found by calculating were 0, h is equal to 0 and h is equal to 4 by 3. Okay, so the function was minus h cube plus 2h square, and the first derivative was minus 3h square plus 4x. Okay, so we need to find the second derivative. So we need to differentiate this once again. So d square f by d h square is given by minus 3 into 2x plus 4. So that's minus 6x plus 4. So d square f by dh square is equal to minus 6x plus 4. So we need to substitute both of these values for x. So when x is equal to 0, d square f by dh square is equal to 4. And when x is equal to 4 by 3, d square f by dh square is equal to minus 4. Okay. So we have already said that when the second derivative takes a negative value, we will have the maxima, and when the second derivative takes a positive value, we will have the minima. So at 4 by 3 we will have the maxima. Let's just check this with the graph. So 4 by 3 will be almost between 1 and 2. Yes, this is that point. Yes, it's true. We have the maxima at 4 by 3 and we have the minima at, we have the minima at 0. Okay, so now we know how to find the maxima and minima, right? So when we have questions like to find the time at which the body has covered the maximum distance, or the time at which the body has a maximum velocity, such physics questions can be solved using by having a knowledge on this maxima and minima. Okay, so that's all for today. I hope you all understood uh, to do the basic differentiation, and also I would like to recommend you all to try out some simple problems from your maths textbook. I will give the exercise number, the specific exercise number in the description box. Also, if you have any other doubts and questions, please make sure that you comment it in the comment box. Thank you.